We saw how to solve case 1 of triangles, oblique triangles, and now we're going to look at case 2, which is the ambiguous case. So as a reminder, the ambiguous case is when you're going to be given two sides and one angle. But this angle is what I like to call associated. It's associated to one of the sides. So it will match one of the sides. So for example, little a, little b, big A. You could also be given little a, little b, big B, but you could not be given little a, little b, big C. That's going to be case 3, which will not be the ambiguous case. So anytime that you are in the ambiguous case, what you're going to need to do first is to find the height of the triangle. And depending on the height and depending on how the two sides that are given compare, you are going to either have 0 triangle, 1 triangle, or 2 triangles. Hence the name ambiguous. So you're going to have 3 different scenarios. So scenario 1, scenario 2, and scenario 3. Okay, in all of them, I'm hypothetically going to look at little a, little b, and big A. So based on this, what I would have is I know that angle A would be down here. And then across from angle A would be side A. And then side B will either be down below or to the left. And I'm going to put it to the left, but it would still work if it was down below. So what you are searching for here is you're searching for the length of this side, the angle here, and the angle over here. Now, first you're going to find the height. The height is going to go from the vertex of the two sides that you know, that you are given. And the height always creates a perpendicular to the base. So this is h. Now, because it creates a perpendicular, a right angle, we're going to be able to use SOHCAHTOA with angle A, H, and B. And because I'm given opposite and hypotenuse, I'm going to use sine. So I have the sine of A is equal to opposite over hypotenuse. And when I solve for the height, I get that the height is B sine A. Now, if the height, I take a look now at the side, I did not use, which was the side here, A. And this is when you start comparing. If A is less than the height, then you have 0 triangles. I'm missing an L. Here we go. Now, why is that? The reason that is because side A needs to connect to the bottom of the triangle. It needs to close the triangle. But if A is less than the height, it's never going to be able to touch the bottom. So you can think about it like a little T-Rex arm, like the T-Rex is trying to reach, but it just can't. It's not long enough because you are trying to create a closed triangle, otherwise it's not a triangle. And if A is less than H, it's impossible to do that. So this right here won't ever touch the bottom. So you will have 0 triangles. Okay, let's look at scenario 2. So we begin exactly the same. We have angle here. Oops, not very straight. Let's try again. Okay, so here's angle A, here's angle B, side B, side A. And then again, I have the height of the triangle, which is going to go straight down, create a perpendicular. The height is still the same. It's B sine A. But now imagine that the values are different and that A is greater than H. So it will definitely touch the bottom. And if A is less than B, so it's greater than H, but less than B, you will have 2 triangles. Now, why is that? The reason for that is because I'm trying to connect to the bottom here. And imagine this is swinging, right? I'm trying to connect it, so I'm swinging. If A is less than B, it will hit the bottom 2 times. It will hit the bottom on the right of H, and it will hit the bottom on the left of H. So the 2 triangles that you're going to have are the triangle that looks like this and the triangle that looks like this. Now in both situations, this is B, this is A, and this is little a. So none of that changes. Now, when you're solving, and we're going to do that in the next video, so you don't need to worry about that just yet. The first thing you're going to solve is for the angle across from the other side that's given. So I'm going to call this B1. I need to add a 1 because there's going to be 2 of them. And then here, this is going to be B2. And the way that you're going to go from one triangle to the next is that actually B1 and B2 have a special relationship, and that's that they're supplementary. And that's going to come from the properties of parallelograms and parallel lines and so on. So you don't need to worry about that so much, but you do need to understand that B1 and B2 are going to be supplementary to each other. So we're going to use that when we're solving. Now, scenario 3. Again, we begin the same way. So this is A, this is B, this is little a. And as you can tell, I'm starting to make A bigger and bigger every time in the diagram. So this is perpendicular, this is H, this is still HB sine A. And now I have that A is still greater than H, because we already know if it's less, you don't have any triangle. And then A is also greater than B. In this situation, you're going to have one triangle. And the reason for that is because when you are trying to swing and connect to the bottom, if A is greater than B, it's going to go to the bottom on the right of H, but then when you swing it, it's never going to connect on the left. It's going to go too far out because it's bigger than B. So in that situation, you only have one triangle. So as you can see, the first comparison is comparing to H. So this is why when you are in the ambiguous case, it's very, very important that first you find the height, which we're about to do in the problem. Now, as you can see, I have a little link here, this interactive figure, GeoGebra. Really cool. If you click on that, you will see that the swinging motion that I'm talking about. So if you're like an interactive person and you kind of want to see that motion that I'm discussing about hitting the bottom of the triangle, you can click on that and you can change the values of A, B, and A. Okay, so let's find, before we start to solve, let's just try to see how many triangles exist. Anytime you're in the ambiguous case, you will always first figure out how many triangles you have before you solve. So we are given little a, little c, big A. This is definitely case 2 because the angle that's given matches one of the sides. That means that you're in the ambiguous case, which means that first you're going to find H. H is going to equal to. So there's actually a very easy way to remember what H is going to be. The letters here, I'm going to highlight it, are always going to be different. So it's going to be the sign of the only angle you're given, because remember, you're only given one angle, times the side that's not associated to the angle. And that's because you're going to have to use SOHCAHTOA. So if I was to use that notion, I'm going to have the sign of the only angle that's given to me times the side not associated to that angle. So these cannot match. And if I was to draw a little diagram of that, this would be A, this would be little a, this would be C, and this would be H here. So that's why I would use SOHCAHTOA with these letters. So when I plug that in, I'm going to get H is going to equal to, oh, that's fine. What is C? C is 9 sine of 45 degrees, which is going to be radical 2 over 2, and we're going to round to the nearest tenth, and that's going to give us approximately 6.4. So the height is 6.4, and now we use the letter we haven't compared anything to. Oops, I didn't mean to do that. Wrong tool. Here we go. So A, which is 4, is less than the height. So you're going to have a little T-Rex arm. Your triangle is not going to be able to close, so you're going to have 0 triangles. It's unsolvable. You cannot solve. Let's take a look at another one. So we're given little b, little a, big B. Definitely case 2, because the angle matches one of the sides, which means that you are in the ambiguous case, which means that you need to find the height. So the height is going to be equal to the sine of the only angle that's given to you times the side that doesn't match. So when I plug that in, I get 7 sine of 35 degrees. And rounded to the nearest tenth is going to be approximately 4.0. It's actually not 4, it's like 4.01 and so on, but to the nearest tenth it is. So the height is 4. And then I compare it to the letter I haven't used yet, which is letter B. B, which is 5. So B is definitely greater than H, because 5 is greater than 4. But B is less than A because B is less than 7. So when you swing the arm, it's going to hit the bottom 2 times. It's going to hit it to the right of the height and to the left of the height. So you're going to have 2 triangles. Let's try one more. So I'm given little c, little b, big C. I am definitely in case 2 because the angle matches one of the sides. I am in the ambiguous case. So I need to find the height. I know I'm being really repetitive, but one of the biggest issues I've seen in the past is that people don't understand that they're in the ambiguous case, and they don't understand that they need to find the height. So this is why I'm really trying to repeat it over and over again. So the height is going to be the sine of the only angle that's given to you times the side that doesn't match. So when I plug that in, I get 3 sine of 50 degrees. So 3 sine of 50 is going to be about 2.3. So the height is 2.3. So then I compare it, use the letter I haven't used yet, which is C. So C, which is 4, is definitely greater than the height. And C is also greater than B. So when I swing it, because it's greater than B, it's only going to hit the bottom once. So you're only going to have 1 triangle. Now, if the height required a calculator, like the sine of 50 or the sine above of 35, like if it wasn't angles that we knew, then I would give the height to you, and then you would just have to compare the sides to the height and the sides to themselves. So in the next video, we're actually going to solve these types of triangles.